Okay, so moving on to quiz 10A, we're talking about multiple regressions. Question A, we're given a multiple regression formula and all the values for the variables. Seems like you can't get it wrong, although I somehow did. Anyway, this is what you get in the end. This is now correct. You get, once you plug everything in, you get 10.866. Only thing you need to pay attention to is he said round your answer to the nearest dollar. So you do need to convert this to dollars, which means multiply by 1,000. And that's about all there is to that question. Question B is probably the trickiest part of this exam, of this quiz. He asks for the standard error of prediction S. Well, we know that S is equal to the square root of RSS over n minus k minus 1. We know that n is 506 because that's the number of data sets. And k is 3 because that's the number of predictors. But we don't know RSS. But we do have a way of getting RSS. We know that r squared, which we are given, is equal to 0.5448 is equal to 1 minus RSS over TSS. And we don't know TSS yet, but we do have a formula for it. TSS is equal to n minus 1 times your standard deviation of y squared. So n minus 1 is 505. And then at the top of the page, we're given the standard deviation of y, which is 9.2. We're going to square that. So all total, you get TSS is equal to 42743.2. So now we are going to work our way up. So this was the r squared that we have. So 1 minus RSS over 42743.2. Solve for that. RSS is equal to 19456.705. So now we have all the data we need to solve for S. S is equal to the square root of 56.705 over n again is 506. K, which is the number of predictors, is 3. N minus k minus 1. Solve that guy out. You get 6.2356. And then you just multiply to get your solution of 6236 as your standard error. Question C tells you that what happens if you hold both RM and DIS constant? Would it go down? Would the market value track with the amount of nitrous oxide, the concentration of nitrous oxide? This is a really simple question because what he's saying is that if these two are being held constant, that means this entire term is a constant. So if we want, we're actually just going to erase this, and we're just going to write this as some value, beta, okay? So now you look at this, this is a linear equation. You get y is equal to negative 10.2 plus beta, this whole thing is a constant, minus 23.84 NOx. So, based on this linear equation, yes, it is true that market value will indeed go down as the concentration of nitrous oxide goes up. That, of course, leads to the obvious question that he would probably ask, question D. Should we eliminate nitrous oxide? Would that increase market value completely? Obviously, that's false. Besides the association causation as usual, if you want an alternate solution, it could be that you can't even get rid of all that nitrous oxide. Like beyond a certain point, you just can't get rid of it. Or getting rid of nitrous oxide might introduce other toxins.